everyone. When humans are speaking to one another, they speak in a particular language. This language is made up of words and letters. Although we type words and letters in the computer does not understand the words and letters. Rather, those words and letters are translated into numbers. Computers talk and understand in numbers. As a computer programmer or an IT professional, we need to understand the four most common number systems that are frequently used in computers. So in our previous class also we saw about different number systems. And now in this video you will learn about how to convert one number system into the other. So now first let us revise about the number system that we have discussed in our previous class. So now we have four types of number system. First is binary. In the binary number system, the base is 2 and the digits used, they are 0 and 1. So it is the combination of the 0 and 1, and with the combination of 0 and 1 the binary numbers are formed. For example, 1 1 1 1 and then 0 0 0 and then base is 2. So this is the way how this binary numbers are formed. So and then octal number system, the base is 8 and the digits used here are how many? 8 digits, and they are 0 1 2 3 4 5 6 7. And then for example, now out of these 8 digits only these 8 digits are only used for the formation of this octal number. And for example 360 and to the base 8. So your base is how much? 8, since 8 digits are used. And now next is decimal number system. In decimal number system, the base is 10 and total number of digits they used are 10 digits. So which are the 10 digits? 0 1 2 3 4 5 6 7 8 and 9. And for example, now the decimal number system, in decimal number system the numbers are composed of these 10 digits only. And now example is 240 and then base I have given over here 10, because here total number of digits used are 10. So now next is hexadecimal number system. In hexadecimal number system the base is 16 and the digits used are 0 1 2 3 4 5 6 7 8 9 and then A B C D E and F. So here the value of A is after 9, it is the value of A is 10 and then B is 11, C 12, D 13, E 14 and the last F is 15. The total number of digits over here is 16, so we will take the base of these hexadecimal number as 16. Example F0. So this is an example of hexadecimal number. So now how to convert from one number system to another we will see in this lesson. So there are three types of conversion: decimal number system to other base, for example decimal number system to binary number system, and other base to decimal number system, for example binary number system to decimal number system, and then other base to other base, for example binary number system to hexadecimal number system. So let us about them, let us study about them one by one. So now first we will see decimal number system to other base. To convert number system from decimal number system to any other base is quite easy. So you have to follow just 2 steps over here. What are the 2 steps you need to follow? First one, divide the decimal number system. Whatever decimal number is that, you have to divide that number by the base of target base system. For example, binary number system, it is having the base 2, so divide that by 2. And if you need to convert into octal, divide that number by 8. If you need to convert that in hexadecimal, divide that by 16. And then write the remainder from step 1 as a least significant bit, that is LSB, which we have already discussed in our previous class. To step last as a most significant bit, that is MSB. So let us take few examples. You will write this in the opposite manner, right? From this most significant bit to least significant bit. So how will you write now? 1 1 0 0 0 0 0 0 1 1 1 0 0 and then 1. And now since this is a binary number, so you will give the base 2. So I hope you have understood decimal to octal conversion. So how will you convert from decimal to octal? So the same number I have taken 1 2 3 4 5 example. So here octal, it is having what? The base is 8, no? So because 8 digits are used in this, so that's why we need to divide this 1 2 3 4 5 by what? Which number? 8. So now when you will divide, you will get the remainders. You will note down the remainders over here, and the first, this one is what? LSB, that is least significant bit. And then the last one, this is MSB, that is most significant bit. So after dividing this, 8 1 is 8, and then you will get how much remainder is left over here? 4 and 43. So 8 5 is 40, and then again 3 is left, and 3 will combine with 4, 34. So 8 4 is 28. Sorry, 8 4 is 32, and then this 2 will combine over here with 5, and then 8 3 is 24. 1 is the remainder, so you will write over here. So similarly you will keep on dividing, and then you will write the remainders over here like this in a step by step manner. And after writing the remainders over here, you will note that your remainder doesn't go above 8. So your remainder remains up to 7. If it goes above 8, then you are wrong. So now after calculating all these remainders, then you will write from the most significant bit to least significant bit in the opposite manner. From the from lower side to upper side you will go. So now how will you write? 3 0 0 7 1, and then the base is 8 over here. Since octal number, there are 8 digits used in the octal number. And now next, now let's see the conversion from decimal to hexadecimal conversion. So now here again I am taking a simple example. Decimal number is 1 2 3 4 5, and the base is 10. We need to convert this into hexadecimal. Hexadecimal, it is having the base 16. So we are dividing this number by 16. So when we divide the first 16, we are dividing 1 2 3 4 5, and then we are getting the remainder this 9, and this is the first remainder. So that is why it is the least significant bit. And then again we are dividing by 16. Keep on dividing until and unless you get number less than 16. So at last, when you get number less than 16, you can stop over there. So now this last one number is what? It is the most significant bit. And similarly you can write now, while writing in the hexadecimal number, you will write in the opposite manner, right? From this bottom to top. So 3 0 3 9, and then base is how much? 16. So this is your answer now, result. So now next example, I have taken a different example here. This in hexadecimal you got only digits less than 9. When you get digits, a different digit like here, you can get a remainder more than 9 also. Here you have got the remainder 9 or less than 9 only. So when you get remainder more than 9, what to do? And less than 15, then you will do like this, right? So for example, I have taken another decimal number 725, and to the base 10 you need to convert this into hexadecimal number. So you will divide by 16 and then remainder you will note down over here. So first when I divided this 16 and then I got the remainder 5, and then again I got the remainder 16 to is 32, so I got the remainder 13, and at last 2 is the remainder. So now here I got a number more than 9. So when you get the number more than 9, I already told you this the value of A is how much? The value of A is 10, and then B is 11, C is 12, and D is 13, E is 14, F is 15. So here you got 13, so 13 is getting converted into what? D. So now you will write this as 5D2. So this is 5 is what? Least significant, and 2 is most significant. So right from the opposite side, 2D 5. So this is your hexadecimal conversion. Once you get the this remainder more than 9, you need to convert. Otherwise you don't need to convert. I hope you have understood. Next, now other base system to decimal number base. To convert number system from any other base system to decimal number system, you have to follow these 3 steps. If you follow these 3 steps one by one, then you will be able to convert. So determine first the base value of source number system. What is the base value of source number system that you want to convert? And also determine the position of the digits, in which position they are lying. First digits in the position 0, and second is in the position 1, and so on. So multiply each digit with its corresponding multiplication of position value and base of source number system, and then add the resulted value in step B, and then you will finally get the answer. So now explanation regarding examples. Below given exams contains the following rows. Now row 1 contains the digits of number, and that is I'm going to discuss this now in rows and columns. So row 1 contains the digits of number, and row 2 contains the position of each digit in the number system. Row 3 contains the multiplication, that is digit into base of the number system, and then to the power position. And then row 4 contains the calculated result of step C, and then add each value of this step D, and the resulted value is the decimal number system. So let us in the explanation like this you may not be able to understand. When you take an example, you will be able to understand better. Now for example, from binary to decimal conversion, how will you convert? So if you follow these 4 steps, you will be able to convert. First write like this, how long it may be, you will be able to convert very easily. Then you will write like this, and after writing like this, first determine the position. So here start from right side. This 1 is in 0 position, 0 is in 1 position, this 0 is in 2nd position, and this is in 3rd, this 1 is in 4th, and this 1 is in 5th position, this is in 6th, this is 7, 8, and so on. So if you have less digits also, then you may sometimes you may have only 4 or 5 digits, sometimes you may have 7 digits. So yeah, it depends. So I have taken a little bit long digits so that you may not have any problem while converting even long digits also, long binary numbers also. So now after writing the position of these all digits, then second step, multiply these digits with 2. 1 into 2, 0 into 2, this here it is 0, so 0 into 2, here it is also 0, so 0 into 2, and 1 into 2, and this also 1 into 2, and this also 1 into 2, and this is 0 into 2, and this is also 0 into 2. Like this you will multiply each and every digit by 2 and start giving these powers now according to their position. 0, and here the position is 1, so to the power 2 to the power of 1, and here the position is 2, so that's why 2 to the power of 2, and here the position is 3, so that's why 2 to the power of 3, and here the position is 4, so 2 to the power of 4, and so on like that. 6, 7, 8, 9, 10, 11, 12 and 13. And now you need to calculate this. So now 2 to the power of 13 is now how much? 2 into 2 into 2, like that. You need to multiply 13 times. So it's not 13 into 2, but 2 into 2 into 2 into 2 into 2, like this. You need to multiply 13 times, right? So and then similarly this also 2 into 2 into 2, like that. You need to multiply 12 times, right? And then 0 into anything, just you can write 0 only. Here is also 0, so here also 0, so here also 0, here also there is 0 into times anything, 0 only. 0 times anything, 0. 0 times anything, 0. You don't need to calculate that all. Now come on to over here. So 2 to the power of 5 is what? 2 into 2 into 2 into 2 into 2. That is 2 multiplied 5 times. And then 1 into 2 to the power of 4. 2 to the power of 4 is how much? 2 into 2 into 2 into 2. That is 2 multiplied 4 times. And then again here 2 to the power of 3 is how much? 2 into 2 into 2, that is 8. So this 0 multiplied by anything, already you can keep it as 0 only. You don't have to do hard work over here. So 0 multiplied by anything, here also 0. And the last one, I already told you in my previous class also, 2 to the power of 0 is how much? Now anything to the power of 0 is 1. So that's why 1 into 1 is 1. And then now your last step is what? You need to add this all, and then after adding you will get the final answer. So now here this binary number is getting converted into this. This is what? This is in the decimal form. So now again here we will see the conversion from octal to decimal. So I have taken a small example over here, 30071. Since the base is 8 in octal number system, so I have kept over here 8. So now how will you convert? First write in this table form. So 30071. Now in the next step you need to write their position. So 1 lies in which position? 0 position. 7 lies in 1 position, and 0 lies in 2, and 3 and 4, so on. You will start from this right side from 0, and then you will if there are more digits you can continue after this 4 also, 4, 5, 6, 7 and on. So on. So and then in the next step what you will do, you will multiply these digits with 8. So multiply by 8, 3 into 8 and 0 into 8, 0 into 8, and this 7 into also 8, and then 1 also in 8, 1 also into 8, and then you will keep the power of this 8 only. So why we are multiplying this by 8? Because we need this octal number system, it is having the base 8, so that's why we are multiplying it by 8. And then what you will do, you will keep the power. So now power we will keep according to their position. So if one position is in 0, so we will keep the power of 8 as 0, and then this 7 is position at 1, so 8 to the power of 1, and 0, this 0 the position is 2, and then 8 to the power of 2. So this 0, it is the position of this 0 is 3, so that's why 8 to the power of 3. The position of this 3 is now 4, so 8 to the power of 4. Now calculate this. So 3 into 8 to the power of 4 is how much now? 8 into 8 into 8 into 8 4 times, and then 3 into 3. So you will get how much? This one, this much. And then 0 into anything you can write, you don't have to do any hard work over here, just write 0. Here also 0 into anything you can write it as 0. And now 8 to the power of 1 is 8, and then into times 7 is how much? 56. And then again here anything to the power of 0 is how much? 1. So 1 into 1 is how much? 1. And now you will at last you will add all these, and then after adding all these you will get how much? 1, 2, 3, 4, 5. Check this and practice yourself, and then at last you will get the finally the converted value is how much now in decimal number? 1, 2, 3, 4, 5. Since the decimal number it is having the base 10, so I have written over here 10. Now next hexadecimal to decimal conversion. So now here also I have taken an example 2D5. Now since hexadecimal it is having 16 base, 16 digits are used, so that's why what 2D5. And now first write like this 2D and 5. Here I have just taken D only. If it is A, if it is B, you have to take values accordingly, right? So I have already told you the value of A is how much? 10, B is 11, C is 12, D is 13, and then E is 14, F is 15. So like that you will take if any alphabet comes from A to F. So here first 2 and then D is as you know I have already told you 13, the value of D is 13, and the value this last is 5. Now position their position, 5 is positioned in 0 and D is in first position and 2 is in which position? Second position. So now since the base of hexadecimal number it is 16, isn't it? So then we are multiplying each and every digit by 16. So 2 into 16 and 13, this is 13 into 16 and again 5 into 16, and then we are again calculating the values of this. Now 16 times 16, 16 to the power of 2 is how much? 16 into 16, and then again times 2 also here into 2. So that is 512, and then 16 to the power of 1 is 16, and then in times 13 is how much? 208, and then again here anything to the power of 0 is 1. So 1 into 5 is how much over here? 5. So like this you will convert, and then you will finally add it up, and then after adding it up you will get this much 725, and then here the result, the decimal number is how much? 725 to the base 10. Since the decimal number is number system, it is having the base 10, so that's why. So now hope you have understood this conversion. You will get if you have any problem you can connect me. Thank